Hello and welcome to the Machine Learning Podcast, the podcast about going from idea to delivery with machine learning. Data powers machine learning, but poor data quality is the largest impediment to effective ML today. Galileo is a collaborative data bench for data scientists building natural language processing models to programmatically inspect, fix, and track their data across the ML workflow, from pre-training to post-training and post-production. No more Excel sheets or ad hoc Python scripts. Get meaningful gains in your model performance fast, dramatically reduce data labeling and procurement costs while seeing 10x faster ML iterations. Galileo is offering listeners of the Machine Learning Podcast a free 30-day trial and a 30% discount on the product thereafter. This offer is available until August 31st, so go to themachinelearningpodcast.com/Galileo and request a demo today.
Your host is Tobias Macey, and today I'm interviewing Wojtek Kuberski about NannyML and the work involved in post-deployment data science. So Wojtek, can you start by introducing yourself?
Absolutely. So thanks for having me, Tobias. I'm a co-founder at NannyML. What I do is basically everything that's related to tech. So I kind of manage the product side of things, the research side of things, which are actually separate at NannyML because we are a deep tech company. My background is in mechanical engineering, and then I did my master's in artificial intelligence in Belgium, where I stayed for a while. I freelanced for a bit, started my own consultancy, handed off the consultancy to someone else. I moved to Portugal for, the sun, the food, and everything else that you can get here. And yeah, that's basically me.
And do you remember how you first got started working in machine learning?
Yeah, so that is, I think, a typical story when you come from physics backgrounds or mechanical engineering background, is that my bachelor thesis was about optimizing the shape of wind turbine blades and generally wind turbine stuff. And then I realized I actually enjoyed the optimization and computational side more than the actual physics. And then since I'm a very lazy guy, I wanted to automate it all. And that's where machine learning came in handy. So I basically decided that let's just try to optimize everything and automate everything. And machine learning is really the tool for that. The algorithms themselves were just really, really interesting. So that's basically when I made my decision to kind of switch from mechanical engineering to AI. And I got lucky that I got accepted to one of the masters in AI. So I didn't have to kind of start from scratch with my education. And that was really it.
So as you mentioned, now you have co-founded a business in NannyML. I'm wondering if you can describe a bit about what it is that you're building there and some of the story behind why you decided that this was the problem that you wanted to spend your time and energy on.
I started previous company, a consultancy, together also with my current co-founders at NannyML. And our goal was always to find a product that we could make big, basically, some unfulfilled need that we could try to fulfill. And we had a couple of ideas, but there was one thing that really came up over and over again with our consulting clients, is that there was the question of what am I going to do after you deploy these models for me? How do I make sure that these models actually keep on working? And we couldn't really make it our problem as part of the consulting because it was way too big to just do it as a kind of one-off project. So we decided it's not our problem. Yeah, you need to deal with it. We deploy your models for you, and that's it. And then after a while, since it was really a pattern, we decided that if we can make it our problem, we could probably actually create a great company and a great product. And there's also kind of a lucky coincidence that we had a mentor, and we still have a mentor, that built a unicorn. And basically, he kept on pushing us to actually jump into product already. There's no point in staying in consulting. So this was kind of like a perfect storm of opportunity, right mentor, and the right pull from the market, because I was actually a pull from the market. And then we decided to ditch the consultancy and start basically go all in with NannyML, raise funds, and build the product.
In the landing page and some of the marketing material around NannyML, it brings up this concept of post-deployment data science, which is what you were saying about you build these models, you hand them over to your clients, and then they say, what do I do with it now? And I'm wondering if you can give your definition of what that term encapsulates and some of the ways that it differs from the kind of metrics and monitoring approach that a lot of people have been falling into because it's something that they're familiar with from application or infrastructure.
It's basically exactly what you said, that there is right now this kind of default approach to ML ops that it's all about engineering. And what we notice is that data science has always been about providing business value and finding insights in data that allow you to bring some value, extract some insights. And this, for the time being, really most of the time stops the moment you finish developing your model. And we think that if you extend this concept of let's try to bring insight, let's try to ensure the value is there to everything that happens after deployment, this is really the key to make sure that your models keep on delivering value. That's kind of fluffy, but to be a bit more specific, what we mean by post-deployment data science is doing things like monitoring, of course, but from the performance perspective. So we want to make sure that performance of your model stays high. And if something goes wrong, then we employ data science tools to find out what went wrong. So we have data analysis. We are doing actually machine learning on top of your machine learning models to figure out what went wrong and then how you can make sure that your model is fixed. So it's not from the engineering perspective, uptime, throughput, whether the model pings, but looking at all kinds of silent failures that can happen and then trying to analyze using data science tools to figure out what went wrong and how we can fix it. That's basically it.
As far as the current state of affairs where you have data scientists and ML engineers building the models and then handing it over to operations teams to manage the deployment and upkeep, I'm wondering who you typically see as being responsible for that work of the care and feeding of the model after it has, gone past the training phase and you have that artifact to be able to put into production. And I'm wondering how you think about the design of NannyML for being able to help those people kind of augment their skills and also being able to loop those data scientists and ML engineers into that overall workflow.
Yeah, so that is something that we're honestly still kind of figuring out. Identified kind of three main persona or three main kind of roles that could benefit from NannyML. The first one, and the kind of people that are most interested in NannyML, is actually heads of data science, because these are the people who really answer to upper level management with the actual performance and the impact of their algorithms. So that's one thing. They need to have a tool like NannyML to make sure that the algorithms actually deliver value, but they will not be the ones using it day to day. They have the need, but they are not the end user. And then the end user we see is kind of, in a sense, maybe not equally split, but split between data scientists and ML engineers. And so far, we see that it's more data scientists that kind of want to make sure that the models keep on working, the models that they develop, so they still feel the ownership that this is my model. I want to make sure that it keeps on delivering value. And also their skill set is kind of more suited for monitoring, because again, post-deployment data science, it's not so much about engineering, but actually understanding what's going on. But of course, when it comes to deploying NannyML to production to make sure it can provide the insights on like day-to-day operation, this is something that will be handled by ML engineers. So in a way, it's similar to the models themselves. When you need ML engineer to deploy NannyML to monitor your model, and then you need a data scientist to actually look at the data, analyze the results, and see if something went wrong. How can I make it right?
Given the fact that the data scientists are interested in being involved in the continued care and feeding of the models and understanding more about how the models are operating past the training cycle, I'm wondering what have been some of the points of friction that they've experienced previously that maybe prevent them from being able to be more involved in that process, and that has led the current state of the industry more towards this just, collect some metrics and try and figure out, has this crossed the threshold of whether or not you need to care about it?
So I think that the biggest problem is really that people had assumed that it's unsolvable. And it's something that has been a problem since machine learning production existed, that models fail. But from a lot of our early design partners and early users, we heard that, yeah, that's how it is. This is just a reality of life as a data scientist. So the first thing is really awareness that you can actually make sure that your models work well, and if they fail, find it faster than you normally would. So that's the first thing. Another thing is we are still extremely early on when it comes to adoption of data science. We're kind of in a bubble when, work in cool companies that actually work with machine learning. But when you look at the general market, there is a lot of prototyping. And I think we're just simply too early. You first need to put models in production to monitor them. So I think right now we're kind of crossing this threshold when data science is, as they say, crossing the chasm, models are actually making its way to production, and people start to realize that the problem exists and the problem is solvable. And when it comes to kind of the friction points or maybe the examples of what prevented them, first, it's just on the kind of, especially in big organizations, on the political level, when there's different person responsible or even different departments responsible for deploying models and maintaining them and making sure there is an impact. And that I think is something that will change in the future when there's going to be maybe even a new role of a person that actually makes sure, like a post-deployment data scientist or production data scientist, the person who makes sure that these models keep on delivering value after they've been deployed.
As far as just the overall state of data science and the health of the models that are being built and deployed, I'm wondering what you see as the long-term effects of having the data scientists more involved in the post-deployment stages of the model development and the ways that gaining better understanding of how the model actually operates in the real world allows them to bring that learning back into the process of developing the models in the first place, or developing successive models about how to learn more about the real world impacts of machine learning, both the model on the real world and the real world on the model, and kind of some of the ways that that will feed into kind of the ongoing research and development, both in companies and in academia.
That is actually a very insightful question. And like you mentioned, there's definitely this feedback loop between the real world and the model itself. If you deploy, let's say, a churn model and the model works well, reduce the churn, which will also impact the population. So we're going to have some kind of drift there already, which might mean, for example, that looks like the model is going to shit, but in reality, the model is still working well. It's just the population is changing. So one thing that people will definitely understand better, the data scientists that are working on these models, is how real world interacts with the model, and that it's a two-way interaction. It's not just that model interacts with the world and changes the world, but also the other way around, because the population will change, and if you retrain the model is also going to be significantly different. And another thing is, I think people will understand robustness much better, as right now you can spend weeks of compute optimizing your hyperparameters, and most people know that they shouldn't evaluate things on the test set more than once, but they still do it. And they just keep on looking for, set of hyperparameters that performs best on your test set instead of your validation set. And they know that this idea of holdout is needed, but they don't really take it to the extreme as I think they should. And when you deploy models, you will really start realizing that things are not as robust as possible, especially if you spend a lot of time optimizing your models and you're just getting good performance due to luck and due to just trying out and actually overfitting in some more subtle ways. And I think awareness of that will increase as you see that when you deploy your models, performance drops compared to your tests, even though it shouldn't, but it still does. And people are asking why and finding the answers to that.
More on the monitoring and alerting side of things, I'm wondering what are some of the ways that you have experienced model failures and some of the particular pain that you've encountered in terms of the available tooling, the visibility or lack thereof, and some of the ways that that has motivated you to want to invest the time and energy on solving this for everyone.
So as I mentioned, kind of moment when we became aware of the problem was during our consulting days. And one very interesting thing that happened is that we were developing a segmentation model that would remove background from industrial tools. And they would be put in a catalog. So basically full automation use case. And interestingly enough, somewhere through the process, as the model was being deployed, they changed the cameras. And the model really went to shit. And it was something that, of course, we couldn't have predicted, but it made us realize that things change in the real world. And as they do, the models will not perform well, and failure is inevitable, just part of life. Things change, and we need to be able to monitor that. Another interesting use case that I stumbled upon a bit more recently is in wind energy, where what you see is that there's always covariance shift, so change in your model inputs, also known as data drift. And there, it really, really impacts the performance. There is no change in the patterns because it's all based on physics, so there's no concept drift. but change in just how data is distributed will have a huge impact on performance. This is something that happens seasonally, and you should know whether you should be worried about that or just normal performance. So just monitoring how your model is performing is not even enough, because maybe this is something that's expected. Maybe as weather changes, there's more gusts of wind. If there's more gusts of wind, of course, your model will not predict the power production as well as in periods of low wind. So that's another use case. And then when it comes to credit scoring, one thing we noticed is that a lot of credit scoring companies and banks as well have this problem is that they deploy a model and they need to wait for a year, sometimes 2 years before they really get the production targets, when they can actually evaluate the performance of their models. So they're kind of flying in blind for a year or 2 years, and they are using their models in basically the most important use case in their business. So there's a huge need there to know whether to estimate performance in some way, even if with ground truth. So these three kind of things really is what made us think of NannyML and how and the shape it has taken right now, is that you cannot just simply monitor performance because it's not enough. Sometimes monitoring performance is not available, so you need to estimate performance instead. And looking at data drift is important from the performance perspective, but not for the sake of data drift itself, because that is something that will always happen, and it's not necessarily bad if your models generalize well.
Yeah, and to that point of data drift being the kind of most frequently brought up case of issues with model performance or things that you have to watch out for after you get a model into production, I'm wondering what are some of the other kind of more insidious or less understood or less observed ways that models can start to go wrong without necessarily triggering the monitoring that most folks are looking at, where, based on maybe, ROC or F1 scores, or just some of the ways that the model can still start giving you bad outputs without you necessarily noticing it. And, conversely, how tracking these, high-level metrics or these specific metrics that people are able to observe more directly, how that contributes to issues of alert fatigue in ML teams?
That is a very loaded question, so I'm going to answer it part by part. So first, starting with what can contribute to model failure, let's assume that we cannot simply measure performance, as it is the case in actually most of the use cases, because there's either a delay or in automation use cases, we don't have full ground truth. So just measuring F1 or whatever metric you choose is not easily doable or doable at all. And then there's basically two main reasons why the models can fail. The first one is data drift or covariate shift. So the change in the joint model input distribution, to be very technical here. So we're looking at all the features and its joint distribution changes. If that happens, it might mean that your data is going to be drifting to regions when it's harder for the model to make its prediction. Maybe because the model was not trained in this region, or maybe it's a region that, let's say, it's very close to the class boundary. So it's just harder to make the correct prediction. Then you will see that the performance of your model is decreasing. And this is something we can actually fully estimate the impact of covariate shift on performance with NannyML, which is one of the cool, unique features we have. And then kind of second reason why models can fail is concept drift. And concept drift is changing the pattern or a mapping or a function, however you want to call it, between the model inputs and the target. So it's probability of y given x. And that means that basically the pattern that your model has learned during training is no longer, so we will see a drop in performance. So these are kind of two ways that models can fail. Now looking at how they can fail, and you will not even be able to tell by just looking at the metric. One thing is that imagine you have data drift to regions that are less uncertain. So the model performance should increase. But at the same time, you have concept drift. So the pattern changes. So the performance does not increase. And that means that even if your F1 stays the same, in reality, the model is worse. It's not predicting as well as it could be. And this is something you would not be able to see unless you can estimate the impact of data drift on performance. If you do it, you will see that given this data drift, the model should be performing better, but it's not. So something's off. And this off part is the concept drift. So that's one of ways of really insidious silent failure. And also the inverse is true. Like I mentioned in When it comes to wind energy, it might be that you have periods when the model performance drops, but there's still nothing to worry about because there is just a momentary drift to regions that are harder to predict on, like gusts of wind because wind blows from the mountains or something. Yeah, I think that's enough talking for one question.
And in terms of the detection capabilities that you're bringing into NannyML, you mentioned that one of the ways that you're able to identify some of these failure modes that are often silent if you're just tracking, bare metrics is the fact that you need to be able to see based on this prediction and the input data that I'm seeing, I'm assuming that this is going to be the performance that I see, but because the distribution of the data is different than what the model is trained against, the concept drift is such that it's actually degrading the performance despite my prediction that it will get better. And I'm wondering, what are some of the other ways that that predictive capability that you're bringing in NannyML is able to highlight some of these failure modes that are kind of flying under the radar and some of the kind of broader impact on maybe confidence in ML in the organization, just some of the broader impacts that these silent failures have when they come to light, and some of the ways that this greater visibility that NannyML brings allows ML teams to kind of build up better trust in the organization.
That's another loaded question. So again, I'm going to start the first part and I'll try to combine it with the alert fatigue that you mentioned. So one of the things that happens a lot is that people, when they do monitoring, they look at every single feature kind of in a void. And if your model has 50 features, something is basically guaranteed to drift. And just because a drift is significant from a statistical perspective, it doesn't mean it's significant from model monitoring perspective. You could see a very strong drift in feature that's mostly irrelevant, and the model is very robust against changes there, and everything's going to be fine. That's why it's so important to try to figure out what is the impact of data drift on performance. Another thing is that these tests, if you do some kind of statistical test or you measure the difference, some kind of distance between two distributions, they assume that all features are independent. They don't track the change in the correlations or relationships between the features. So they kind of don't think about this joint part of the distribution. And for that, develop multivariate data drift capabilities where you can basically train your data, let's say an autoencoder for the ease of explanation on your data for which you know everything's fine. And then you see how well this autoencoder performs on the dataset in question, your analysis dataset. And if you see a drop in performance, it means that the internal geometry of the dataset has changed. So there's data drift. And this is a way to capture data drift that would not be captured by these tools that just look at everything from univariate perspective. Now, for the second part of your question, which is how monitoring can change, how science fairs can impact the trust in machine learning. I think right now, because the failures are silent, all the failures are not expected and they are seen as something that was not planned, inherently bad, should never happen, it's all your fault. So what monitoring can really bring is first increase the trust that if, let's say, head of data science is reporting that the models are performing well, they actually are performing well because there's much more knowledge in the company. And another thing is kind of bring more understanding that failures will happen, they will be resolved fast, and they're just part of normal operating procedure. Just like you see right now, you need to maintain your physical equipment, and physical equipment will have to be out of operation for a while. The same is true for machine learning models. That things will happen, and model is not performing as well as it used to, and it's going to take us, let's say, 2 days to fix it. That is something that should be normal in companies, but now every time there is an issue, everyone's ringing alarm bells that you cannot trust machine learning and it's not reliable. It's reliable, it's just not perfectly reliable. And if we quantify this reliability, that will bring more trust.
Another aspect of the question of alert fatigue is that if you do get an alert, you don't necessarily know what to do about it, where a lot of the conversation that you see in the ML space is, if you see concept drift, then that just means that you need to go back and retrain your model based on the new data that you have and redeploy it, and everything will be great. And I'm curious what you have seen as some of the ways that teams who are using NannyML, or just this better understanding of what is happening with the model, allows you to think about what actions can and should be taken based on the actual type of failure that you're seeing, and the overall question of what are the remediation actions that can and should be taken when you do see that there is some problem that is manifesting.
So when I think about monitoring, I think there's kind of three parts of it. The first one is detecting failure. The second one is realizing why failure happened. And the third one is resolving the failure. And right now, with NannyML, we basically provide the first and the second. And the third one is, for better or worse, manual. Because what we realized is that it really is extremely use case dependent. The first thing you should do, your default action should be retrain, but instead of redeploying immediately, you should either run an A/B test, and this is something that we saw some people doing, or, and that is a very interesting case, is that you retrain it, but you retrain just on the part of the drifted data, and you see how the model performs on the rest of the drifted data. So you do kind of a phantom deployment. And then if everything's fine, it can redeploy. If not, you need to go back and basically do some kind of root cause analysis, which you can do with data drift capabilities, both univariate and multivariate, and then also, tap into your domain knowledge to see what are the changes in data quality upstream that might have caused the failure. What are the changes in the business side of things that might have caused the failure? Maybe there is a new marketing campaign, and this marketing campaign completely fucked up our recommender system. That's something that might have happened, but a tool like NannyML has no way of seeing that because it's completely external to the machine learning system itself. So there always is a human component needed there because you're basically like an investigator trying to figure out why things happened. And then once you know the full picture of why, it's a matter of retraining or redeveloping your model, maybe with different architecture, maybe by adjusting the data. So if you have a strong data drift, maybe you should adjust your old data, do some kind of shift there to make it match the current distribution, because the model will just get confused otherwise, trying two completely different patterns at the same time. Yeah, I guess that's it.
Another interesting kind of roadblock to the question of just retrain and redeploy it is that sometimes for a particular model instance, that retrain cycle might take, several hours or days. And I'm wondering how that factors into the decision about, okay, what do I do in this instance? Like, is it typically a case of this is an urgent failure and I need to be able to resolve this immediately? Or are the failure modes typically, oh, this is starting to look weird, we need to be able to retrain and redeploy, so let's go ahead and kick it off, and when it's done, we'll get to it when we get to it, kind of a thing?
Oh yeah, that's another interesting question. And you mentioned that it can take, days. But if you look at wider organization, in some banks, it can actually take months because you need to submit a request to retrain a model. It's to be approved by the compliance team. And it really takes ages. One of our data scientists at NannyML used to work at one of the more advanced banks. And even there, just because the regulation is so heavy, you cannot simply retrain your model. You need to go through steps with multiple different teams, multiple different external validators before you can retrain your model. So it's at least a month. And I think that is also why you actually have to retrain your model, or it's nice to have, is important. So again, estimating the performance and monitoring the performance is really the key here. And from there, you can see whether the impact is long-term and severe, assess the severity, assess also whether it's a long-term impact or just passing impact due to seasonality. And so again, data drift, impact of data drift on performance, estimating performance, and measuring performance. Oh, and here there is another actually thing at play, which is the uncertainty estimation of the performance itself. This is something that we will just be releasing to the library in, I think, 2 weeks' time from now, when we'll also be giving the uncertainty estimates on our performance, our calculated performance. So you will not know that, let's say, ROC AUC is right now 0.85, but 0.85 plus minus 0.6. And if you see that you have strong drop in performance, but also uncertainty is really high, maybe that is something that, you just got unlucky with the data. And you should keep on going as it is. You don't have to retrain. Maybe you do, but let's wait and see. So if you combine these uncertainty estimates with the data drift and performance estimation, you should have a full picture of whether you need to retrain or not.
This might be going a little too far afield and too far into kind of the systems design aspect of it. But in the case where you do have a model, it is seeing critical errors in the ways that it is generating predictions. I'm wondering, what are some of the kind of application or systems engineers patterns that you've seen for people to be able to include some sort of a circuit breaker where it says, okay, this model is too far off the rails, we can't trust it, retraining it is going to take too long, so we need to have some sort of fallback mechanism to be able to say, this capability is no longer functional right now, check back later, or, we'll just go with kind of a more statistical heuristic approach that doesn't rely on this more advanced model capability. So we will say, have kind of a graceful degradation of capabilities. The model is no longer in the loop such time as you can fix the underlying problem that it's experiencing.
To be honest, I think that it's a step too far, not necessarily for us here, but for the reality. I don't think we're there yet. Maybe there's a handful of companies that already have those capabilities. I haven't spoken to anyone that actually already had a full-blown system of how to deal with failure. Most of the companies that do monitoring do it manually. Everything is manual. All decisions are basically taken on the spot. And I think we're quite early when it comes to that. One thing I saw is that there is an off switch. If the failure is really critical, to the point when instead of bringing value is detrimental to the company, then the first thing you do is you just turn it off. Or you still run the prediction, but you don't actually act on it. So you turn something off that would actually have an impact. So the model is just running in the void. And then you start resolving the problem. And once the problem is resolved and you confirm that the failure is no longer there, you can deploy the new model. That's basically the only thing I know of.
Yeah, it's definitely an interesting thing to think about, of like all the different ways that things can go wrong and how to resolve them. And at a certain point, you just have to say, I can't predict it. It is what it is, and we'll figure it out when we get there.
Yep.
And so in terms of the NannyML project, can you talk through how it's implemented and some of the overall design questions that you had to address in terms of the technical and user experience interactions and how to be able to fit this into people's machine learning workflows?
On high-level perspective, we decided to go for a Python open source library because, let's be honest, almost all data science right now is done in Python. People want to just install things or conda install or whatever is your preferred method here. So that's one thing. When it comes to the actual implementation, we basically have kind of a default structure, default workflow for NannyML itself. When first you plug in your data, and your data can be in form of kind of one-off analysis. When you have your reference dataset for which you know everything's fine, your analysis dataset for that you'd like to analyze. And this kind of mimics the manual monitoring process when from time to time, let's say every week, every 2 weeks, however often you need to do it, you will manually run NannyML, see what's going on there. And then the flow is that you get your data via Parquet files or whatever you want, or if you have it's a microservice that just provides the data. You see what's going on, starting with performance calculation or estimation, depending whether targets are available or not. Then if everything's fine, you're good. If things are not fine, you need to go into data drift and you'll go do multivariate and univariate data drift detection. And then we have a honestly pretty minimal capability to link data drift to performance. So we'll be able to see what are the potential reasons for drop in performance. And from then on, you go to a manual quest of resolving the issues. That's kind of one workflow. Another workflow is that if you deploy to production. In that case, NannyML is running via Airflow or some other kind of service. We just released our CLI. So right now it's much easier to just run NannyML as part of your ML system. And you get your alerts and you have let's say a script or notebook when NannyML is running when you can just view updated dashboard with however often you want to run NannyML. It can be every 10 minutes, it can be every 5 minutes, and basically as often as you want. There's one thing that I generally like to caution about, which is trying to do streaming with monitoring. And the thing is that you can obviously use NannyML in streaming fashion, but you need to have certain volume of the data before you can say that the performance has degraded. Degradation is like inherently probabilistic process. So if you just get one new data point, it really does not make sense to rerun the whole analysis again because things cannot have changed that much. And even if they do, you will not be able to tell by just one point. And also the algorithms cannot take that. So what I would recommend is basically running batch every few minutes, few hours. How often do you need when you have enough volume of the data? And then if there's alerts, then the rest of the process triggers. And that can either automatically trigger retraining, or in advanced organizations that deal with automation use cases, that could trigger manual spot checking. So then you basically create a task, send a signal to a team that does spot checking, so manually reevaluates whether the performance actually has decreased. And from then on, you can take actions to remediate.
In the process of building NannyML and starting to work with some of the end users of it, I'm wondering, what are some of the initial concepts or ideas that you had about how to approach the problem or how to integrate it into people's systems that you had to reconsider or reevaluate as you started getting it in front of people with real world use cases?
Yeah. So our first idea is to basically market it towards business people, because that is kind of the end consumer. And while the idea is sound in principle, in reality, it really did not work because they just don't understand machine learning at all. That's why you switch to data scientists and heads of data science. Another thing is that we started with a dashboard. People want to view it as a dashboard. What we learned from early user interviews and from early design partners is that people actually don't care that much for a dashboard. Like there's certainly some companies or organizations when they want it, and they care about dashboard as kind of a second step when they deploy themselves via literal Jupyter notebooks. They view things themselves there. Everything's working fine or not fine. And then if there is a problem or they need to communicate it to business stakeholder, that's when the dashboards come in. So then we had to completely change the priorities. We dropped the dashboard. We focused on usability within Jupyter notebooks. And really, in the entire question of UX is I want to run things fast using interface that I know. So we often default to how is scikit-learn doing it? Or how is, when it comes to plotting, how is Seaborn doing it? And we look there and it's our default. And unless we have a very strong reason to change the interface, we basically copy them because they did it well, people know how to use it, and they are happy with these libraries. So I guess that was one big thing we needed to reevaluate. Another one is kind of, we had assumed that the idea of estimating the performance without the ground truth is something that will click in users' head. But we realized it's not as easy, and we had to do a lot of like nudging, both in our documentation and in the visualization themselves, to show that we are estimating this performance. This is real performance. We are estimating what is likely to have happened due to data drift. And this is something still an open question, because for a lot of people, it takes a while to even realize that it's possible to even estimate the performance of a machine learning model. And it's definitely not an intuitive idea.
Another interesting challenge in the ML space is that you need to be able to support a fairly large variety of different frameworks and data types and model architectures. And I'm wondering, what are the initial target capabilities and initial focus that you had for that kind of matrix of use cases, and the ways that you have thought about the initial foundational aspects of building NannyML to allow you to then branch out into, maybe going from tabular data to unstructured data or image data, et cetera, or, the different frameworks that you wanted to support or model architectures that you wanted to be able to understand how to generate these predictions.
So that's something we actually thought a lot about. And what we realized that from the use case perspective, there's basically one huge difference, is that whether the ground truth is delayed or not. If we work with cases when ground truth is not really delayed, so high frequency trading or delivery time prediction, when it's going to take you half an hour to get your targets, that is something that should be monitored in a completely different way than, let's say, loan default prediction for mortgages, when you wait years until you know your target. Then on the model and framework side, we made the decision very early on, also because honestly, we got lucky with research, that we're going to be fully agnostic when it comes to everything there. So we don't actually need the model. NannyML does not need the model file, does not need to know the framework. You just work with data. That was a very kind of committal decision that we took in the beginning, that NannyML should always be able to work with just the data. So then by default, we actually support all kinds of models because we don't need to look at them, all kinds of framework because we don't need to use them. So we managed to kind of sidestep the problem, and so far it's working quite well. Now, when it comes to the actual data types, that is, I would say, the biggest challenge. It's not something that we were able to sidestep. We decided to focus on tabular data because that's where so far we've seen both the value is in the companies, and also this is the type of data that is most prone to failure. Like I always say, a horse is a horse. It's not going to stop being a horse anytime soon. So if you look at image data, it's less likely to change. But of course, as I already mentioned, sometimes the cameras change. One interesting example we got from a design partner is that they were doing detection for COVID based on X-ray images. And there was a new strain. And the model failed because the new strain actually showed itself in the X-ray images differently. So of course, there's truth there, but we decided to focus on churn use cases, credit default scoring, upselling, cross-selling, all this boring AI, because these models are actually in production, and if they fail, that's a huge problem. And now moving on to images and text data. We are right now actually running a small internal project to see what changes we need to do to support them natively. And what we find out is you can already use NannyML for text and image data, but instead of working with the raw data, you need to go to the embedding layer. And there you could basically treat it as tabular data, and performance estimation works well. Multivariate data detection works well. Univariate data detection returns bullshit because you just get pixel values, or you get, the vector 17 has changed. Yeah, that's not interpretable, and that's very useful. So we don't have the interpretability there, but the core capability of drift detection and performance estimation is still there.
As far as being able to integrate NannyML into an ML system, what are some of the foundational systems and capabilities that are necessary to be in place to be able to handle feeding the data into it, generating the predictions, being able to capture the outputs of NannyML and integrate that with the other monitoring and alerting systems that can and should be in place?
So our default kind of workflow is you have your model deployed as a microservice. So first hard requirement is that your model is actually in production, which people sometimes claim that it is in production, but it's actually not in production. Or it's in production, but nobody's acting on the predictions. So one important thing is you should implement an email as you deploy your models or after you deployed your models, but it's a tool for post-deployment data science. So that's one kind of obvious thing, but it's sometimes less obvious than it seems. And then we basically assume that you have a microservice architecture. When you have a model deployed somewhere, it's scheduled via Airflow or whatever you want. And then what you want to do is you want to spin a Docker container, let's say, or however you containerize your microservices with NannyML. And what you feed to NannyML is all the inputs that come to the model and all the outputs from the models. Plus, if you have access to this data, also the target data, the production target data. On top of that, you will need some period for which you know everything went fine. This can be your validation set, or you could just get some production historical data for everything, when everything was fine. Let's say first month of production. And then you just, if you do batch processing, you can query an email at the same time as you query the model. With the same exact data, you first run it through the model, then you get model inputs and outputs to NannyML. And then you will need to have a way to display it. The defaults are, funnily enough, Jupyter notebooks. When you just have NannyML running, it displays the data, you view it in your browser, and that's literally it. So there is not that much to be done on this front.
As far as the kind of post-deployment data science aspect of it, we discussed this a little bit, but what are some of the maybe ways that the outputs of NannyML can get fed into a maybe partner model that sits, with NannyML and, feeds back into the model that you're monitoring, or just, some ways that the information that NannyML surfaces can be used to build additional models to then serve as kind of automated checks or automated remediation flows for the model that you're actually putting into production and is generating the value?
The easiest way is basically the alerts. We have alerts that we return both in visual form and as a data frame. And what you will see there is that if you have alert on performance that can be set with a custom threshold or default threshold, that is the easiest things to act on. So basically you can look at alerts on performance, alerts on data drift, and alerts on specific features. And then you can use that information to trigger first automated retraining. This is kind of the minimal fully automated loop. When you automatically retrain, you pass it through, you deploy the model, and then you pass it through with phantom deployment or A/B testing through NannyML again to see whether the issue has been resolved. If the issue has been resolved with this feedback loop, then the model gets deployed to true production. So that's kind of the default remediation technique. And then you could see kind of another flow. If the issue is not resolved, so retraining is not sufficient, you could pass what has been tried, plus all the alerts, not only on performance, but on data drift, to a data scientist who could get basically start with it as and do an EDA there to figure out what went wrong. And then you go back to the same process when you deploy the model via phantom deployment or A/B testing. You run it through NannyML again and see if the issue is resolved. If the issue is resolved, you deploy the model. So there's this kind of feedback loop approach when you can use NannyML to both alert you that something has gone wrong and confirm that the issue is resolved.
And then in terms of the ways that you're thinking about making this project and business sustainable, I'm curious how you have thought about the kind of governance aspect of the open source project and the ways that the business you're building around that, feeds into it, and just some of the division between what is freely available, what is commercial, and just the overall business model that you're targeting.
So for the time being and for the foreseeable future, we are fully focused on open source, and there is going to be a open source led product. So the open source is going to be always the main thing. And we kind of follow the open core philosophy. When all the core algorithms that provide value and is, new science that we're developing or new engineering at least, is something that's going to be always open source. Right now, we're not monetizing anything. What we're focusing on is adoption first and foremost, trying to get as many people to use NannyML in production in real life use cases. And based on that, we'll be seeking more funding soon-ish. We have a bit of runway yet. And in the future, there's basically two ways we plan to monetize. One is everything that has to do with enterprise edition in terms of security, integration, privacy, helping them basically create workflows, helping big enterprises create workflows where NannyML can be used to provide value, just like the one I just described before. And another thing is business-oriented features. So trying to use additional signals from the business that are not in the dataset to help improve model monitoring. If it's possible to quantify the impact of a model on the business itself, also monitoring those metrics. So maybe ROI on the model. Simple one in credit scoring would be, risk-adjusted ROI on how much money you're getting per loan. Is that changing? How is that relevant to data drift and model metrics? Can we also estimate that? These would be the things that almost nobody cares about except business people. So it's a perfect thing to keep outside of the open source solution because it's something that would not drive adoption, it would not drive value for vast majority of people, but also is a good way to monetize and basically make it a business because if these capabilities are needed, they are really needed and people are willing to pay for them in a way that's, really shows that it provides value.
In your experience of building the project and working with some of your design partners, what are some of the most interesting or innovative or unexpected ways that you've seen NannyML used?
The idea of using NannyML to A/B test models is not mine. I mentioned a few times, but it was something that actually came from a design partner. When at first they were not even interested that much in monitoring aspect of it, but they were doing retraining. And the biggest thing is that they never knew if the automated retraining actually makes sense. Maybe we're actually hurting the model more than we're fixing it. And that is something that actually once happened when there was an upstream data issue. And that meant that basically the quality of, I think, 2 months of data was much lower than the previous months of data. And the model was retrained and the performance dropped significantly because then the model was, even though the data quality issue was found out and resolved. The same data was still used to retrain the model. I don't know why. It just happens in enterprises. And we were able to actually spot that with NannyML. And then that is one way to monitor automated retraining to make sure that you don't do something wrong by retraining your model. I think that was really the biggest one. Another one would be to look at the training set itself and understand it better so it can be used as an analysis tool when you basically want to see what are the changes within the training data and how whether you should use all that data for training or not. So to basically see whether this data is really relevant or not. That's something that normally would only be done in a very manual way. Let's say you have last 20 years of credit scoring. You would know as a person working in finance that everything that happened before 2008 and after 2008 would look completely different. But that's something you need to know. And there's maybe multiple different changes like that you would not be aware of. And you can use NannyML to kind of automatically analyze these changes in the concept in the training and data drift within the training set to figure out which data should be used and which data should not be used to train your model.
In your own experience of building the project and building the business, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
One thing is that we really had no clue how to build a product. And we kind of had a clue how to build a business because we built a consultancy. And the product was like, what's product? Engineer the thing, you do data science, and then you release it. And we really did not realize that there's this entire thing called product thinking. When you need to figure out, combine basic what's needed with how to present it, make sure that there is value, usability, business feasibility, and actual feasibility. And this was something that was completely not on my radar. That was one big piece of thing that I learned. I read a book called Inspired, and that is really something I would recommend to everyone, engineers, data scientists, whoever you are. If you work in a product company, this book is really great. Another thing is the value of early user testing. At first, we decided to build one thing, we built it, and I was like, yeah, it's kind of there. Not really. It works, but not great. And after we hired our product designer, basically we switched to always try to test mocks, prototypes, test as often as possible. And once we decide to build something, we have much higher chances of it being the right thing. And then on top of that, we also are much more committed to actually building things and not abandoning halfway through, because we found out that it's actually not something that people want, because when we build something, we already know that people want it. And last thing I would say is adoption is much more nuanced than expected. We started with pure business focus because that is objectively where the value of data science is, but that doesn't matter. If these people are not interested or don't understand what we're trying to do, we will not be able to bring value to them because they are not open to it. And that's why we decided to switch our focus. And being open to who's actually your user is very important. And focusing on people who will use NannyML immediately is more important than focusing on the person who will, in the end, get some value out of it. Working with engineers is completely different than working with data scientists. They are different people, they are driven by different things, and there's even a huge communication gap between engineers and data scientists. One thing that I notice is data scientists are in general, of course I'm going to make a terrible generalization here, are driven by curiosity. What makes them tick is figuring out things. And with engineers, it's much less so. They are driven by building things. They want to create things. These are completely different motivations, completely different ways of looking at the world. For me, the problem ends as a data scientist when I figure out how to do it. Doing it is like an afterthought. If I already know how it works, that's what I want to. Whereas with engineers, they don't really care that much how things work, but it's about building things. And these things sometimes stand on the seemingly opposite sides of the spectrum, and I had to learn how to recast the problem in different light to appeal to different people.
Yeah, it's definitely an interesting insight about kind of the challenge of being able to motivate people because of the kind of areas of where they want to spend their time and focus and what it is that they are actually intrinsically interested in.
Absolutely. And then you have business people, and most of them, they just want to have one metric and drive this metric as fast as possible. So it's yet another deep motivation. And it's all very interesting.
For people who are deploying machine learning, they have it in production, what are the cases where NannyML is the wrong choice?
So I would say that there are a few use cases when we're just not ready for as a library, as a product. Let's say that you don't monitor at all and you work at JP Morgan Chase and you're responsible for creating the entire platform for monitoring everything. At the same time, you don't have the capability to actually implement NannyML yourself. We wouldn't be able to assist you there, and then probably should look for a closed source solution that would come in with the entire playbook of how to do it for a huge organization and do it from scratch to finish. NannyML is inherently open source product, which means that we expect, we're happy to help and assist with anything that has to do with implementing NannyML or monitoring in general, observability in general, or post-deployment data science in general, but we simply don't have the manpower and the capability to do the integration for you. So if you don't have the capability to integrate NannyML or work with NannyML is not a choice for you. This is true, I think, for most open source projects and just as much for NannyML. Another thing is really big data. We optimized our library. It works reasonably fast. And if you have, let's say, single-digit terabytes of data per day, NannyML is a good solution for you. If we're looking into petabytes per day, this is going to crash. It's not going to work. It's not designed to work with each data.
As you continue to build out NannyML and iterate on the product and add new capabilities, what are some of the things you have planned for the near to medium term, or any projects that you're particularly excited to dig into?
So when it comes to the product roadmap, so we always have like a research roadmap because we are trying to come up with new ways to actually solve the problems that have not been solved before. The main one being, of course, performance estimation without ground truth, but also multivariate data drift detection. And there, we recently figured out how to do performance estimation for regression models. So we will be releasing full support for regression in the coming weeks, to be more specific, within the next 4 weeks. It's going to be in the library. On the short-term horizon, as already mentioned, there is expected sampling error, so kind of a way to measure the uncertainty of our predictions for everything, for data drift, for performance as well. And a bit more long-term, we will be looking into segment-level analysis. So first, automatically segment your data from the perspective of model monitoring, and then run the entire analysis on these segments. You'll be able to find underperforming segments when maybe general population level model performance is still fine, but you have some segment of your data where the model is not performing well, and you should be looking into that. So kind of fine-grained analysis. Then roughly within the same time frame, we have explicit support and full support for text data and for the image data. And then a bit more long-term, we'll be also looking at concept drift detection. So ways to detect not only the data drift, but actual concept drift, and link it to performance. This is something that we just started the research on, but since it's mostly unsolved problem if you don't have access to your ground truth, we are starting with assuming you can access your data, you can access your target data, and we'll be releasing support for that shortly. When it comes to concept drift detection without access to ground truth, this is a really open research problem. But if we are able to really figure that out, we'll be able to almost always estimate the performance of your models quite correctly, which is kind of the holy grail of ML monitoring. But that's a while from now.
Are there any other aspects of the work that you're doing at NannyML or the overall space of post-deployment data science that we didn't discuss yet that you'd like to cover before we close out the show?
Oh, I just remembered one thing about the roadmap. On the integration side of things, so everything related to engineering, we will be definitely looking into explicit integration with MLOps tools to really make deployment of NannyML itself as seamless and effortless as possible. So tools like ZenML and alike, on top of what we have right now with RSCLI and Docker deployment. When it comes to other things, maybe when it comes to learnings and things I learned in my journey is that recruitment is extremely important and hard. But if you spend a lot of time actually figuring out who you want and describing it very well, we actually never had issues with having not enough applicants or not being able to find the person we're looking for. So it's just kind of a fluffy thing. It's focused on recruitment more than you think you should be. The recruitment decisions are really one of the most important decisions you can make in a startup. I think that's it, actually. Nothing specific to talk about. Just, I would like to encourage everyone to go to our GitHub, give it a try. And I am always happy to either assist or receive any kind of feedback. Oh, you always get haters. We got our haters recently, and we actually felt good about it. People bashing NannyML, because if they are, that means that they care, and that's good.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest barrier to adoption for machine learning today.
I think it's mostly the awareness of potential impact. This is not going to be like a popular default answer here, but I think if businesses and executives realize the potential impact of machine learning in their companies, and if they were able to actually track it, they would be much more willing to invest into proper structure and resources into deployment. And if you see the potential upside, problems tend to disappear and get resolved if there is really need for that. Another thing is well-structured processes, not only for developing machine learning models, but also deploying them and monitoring them. And I think right now we have a very strong disjoint between prototyping, deployment, and everything that happens after deployment. What we will hopefully see in the future is that these things will come closer together, and data scientists who develop models will be looking at it also through the lenses of, can I actually deploy this thing? Will it work when it's deployed? And people who work in deployment will realize what happens after deployment. If I deploy it, it's easy to retrain, easy to develop. And people who work in kind of post-deployment data science will be able to look back to two previous stages, kind of make this process really more structured together and not as disjoint as this is now.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing at NannyML. It's definitely a very interesting problem space, and it's great to see folks tackling the question of how do you actually understand what your model is doing in production, and how do you understand what to do about it. So I appreciate all the time and energy that you and your team are putting into addressing that problem, and I hope you enjoy the rest of your day.
Thank you. It was great to be here, and enjoy.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.